Swayam Prabha. Digital India. Educated India.
Okay, let's look at the details. So there are various sub-modules in this particular methodology. Once we get an overview of the modules, then you will understand what it can do, what it cannot do. The first sub-module is very specific to LTS systems. That is why we have spent so many lectures deriving those very ugly looking mathematical expressions, because we need to link the net lift available versus the aerostatic parameters such as humidity, temperature, pressure, superpressure, all those parameters, all those 9 or 11 parameters, we need to establish a link between them and the net lift, because our whole soul net lift is coming mainly from aerostatics. So we need to understand that. Then there is a geometry submodule. This works out the sizing of the fin and the envelope. So I must say that this methodology is only for conventional airships. Airships which will have a single envelope, axisymmetric body of revolution, and they will have a fin. They will have in fact four vertical, 2 vertical and 2 horizontal members, which will be the fins. So we have to figure out some way of sizing the fin. Given an envelope, what would be the appropriate fin? Then there is a drag submodule which estimates the total drag of the airship under some operating condition, and also the main part of the drag of the airship, nearly half, is going to be the envelope. Okay. So envelope drag estimation, and then scaling up by some semi-empirical methods to get the drag of the entire airship. Then there is a propulsion submodule. So given the drag expected at an operating condition, it works out the power required, and given the power required for a particular engine type, it works out the horsepower or weight of the engine and the fuel consumption also. And then we have the weight estimation submodule. So it estimates the weight of gondola components, and it also does some effect of design features and options onto the weight breakdown. So for each of these, separate submodules were created, and these submodules, as I mentioned, are explained in detail. All the formulae which go inside are explained in detail in the papers which I will be uploading, which I will repeat. You are supposed to read and understand, and use the Moodle page for asking any queries that you have about it. Okay, now this methodology works in 2 modes. So let me ask you, already we have done suggestion that why don't we start with the volume first? Okay, what is the basis of your suggestion? It's a right suggestion, but what is the basis? Correct. So once you fix the volume, the net, the buoyant lift or the gross lift will be available as a function of that volume and difference in density, and therefore
we can assume, we can correctly that it can pick the whole weight of the, we can know the amount of weight
it can lift. So the amount of weight it can lift will be equal to the buoyant lift. Okay, maybe with some margin. So that means if you have to carry X kg of payload, then the total buoyant lift minus X is available to you for everything else. Correct? So that is one way of starting. Is there any other way of starting this whole procedure? One way is assume volume, then payload is known to you, do the sizing. Can we do it in some other way? So to answer this question, I think you need to ask yourself, if you are, let us say, a user of an airship or a prospective user of the airship, let us assume that somebody, I am a designer of airships and I am offering you an airship, or I am offering to make an airship for you for your requirement. What kind of requirements will an airline or an operator have when you want to operate an airship? Just list out the requirements. We'll note them down here. Let's see one by one. Okay, so I'm going to note down one by one whatever you tell me as the operating requirement. One by one, please. Yes. Geographical conditions. So what, give me some parameter. So that means operating altitude. Okay. So one parameter is operating altitude. I will call it as HOPER. Okay. At what height the airship is expected to fly? Then payload fraction or payload? No, the user cannot give fraction. User doesn't know what the airship, user says, I have to carry so much. So the next item will be payload to be carried. Okay. Then range. Okay. Then operating hours. Like, what do you mean by operating hours? Endurance. Okay. Yes. What else? Like, what will you say? Type of fuel. Very good. Type of fuel. Okay. Gondola volume. Why will the customer give gondola volume as a requirement?
It depends. I mean, if he wants to use it as a cargo airship or a passenger airship, the volumes will vary depending on his requirement.
Okay. So, shall we say volume of payload to be carried? Let us not assume that it is going to go in the gondola only. So, we will say volume of payload. Speed. So, now there are many speeds. There is a cruise speed, there is a max speed, there is a minimum speed. Which speed are you talking about? So, cruise speed. Okay. Then, yes? Atmospheric conditions. Yes. Atmospheric conditions. So, now you tell me which are the conditions that user is going to be concerned about. So, tell me, what are the conditions? Pressure. Are you really concerned about the pressure? So, does any customer say that I want to fly an aircraft at this ambient pressure?
No, but if the location, right, so for example, somewhere near the mountain,
Yes.
so consequently the load pressure has to get lower so that the delta P doesn't exceed the...
Right. So, this is the task of the designer to decide the pressure inside. So,
Isn't this factor already considered in operating altitude?
just altitude, yes. So, you need, see, the altitude can be 1000 meters in US, in India, in Burma, there will be difference. So, yes, atmospheric conditions are important, but what conditions? Okay. So, one is temperature, right? Then density, it can vary from place to place. The third thing is winds, maximum expected winds. Then what else? Humidity. I am very happy that somebody talked about relative humidity, because we spend so much time in deriving humidity. Then super pressure, superheat. So, super pressure and superheat will come on the basis of how much time will you deploy it in the open. But we will put it, because we know there are methods, superheat plus super pressure. Okay. Anything else?
Cost of manufacturing
Initial cost. So, you are saying that as a prospective customer of the airship from me, you will say, give me this conditions and within so many rupees. Okay. So, I will call it as acquisition cost. Acquisition cost CACQ. Okay. Then operating cost. Operating cost. You will ask me in terms of some passenger per kilometer, operating cost per kg payload per kilometer, something like that. Okay. Then somebody else?
The size, the dimensions.
Dimensions. So, is the customer going to give dimensions?
Yes, sir. You will see I have a hanger of this thing like that.
But the problem is, you cannot expect to give me all these things and the size and say now make it fit in that. Because you might say 100,000 tons but hanger of 2 square inches. But it cannot be, no? But there could be constraints. So this is not a requirement. This is the constraint. Or you can say, I have a hanger of this size. Tell me how much payload can the airship carry? The answer may be minus 10 kg. Correct? Because the size may not be sufficient. So there could be some constraints on size. Anything else that the operator will like to specify?
So what about the moving mast? I mean, he could give you the requirement of having a movable moving mast or a static.
Correct. So I would just call it as ground support equipment. The user might say, I want to operate this airship with only 4 people on the ground. Or you might say, don't worry, I have lots of young people jobless. I'll hire 100 of them. And don't worry, save money on complexity of mooring, give me a very low operating cost airship, manpower is easily available. This could also be an operating device. So that's why ground support equipment. Okay, now anything else you would like to specify? So from the point of view of the design, in this methodology we have only 2 possible modes. The first mode is called as a forward analysis. Here we say the envelope volume is fixed. For the given operating environment, etc., 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 how much payload can be carried. So this particular analysis loop, this is not design, by the way. This is analysis. No? So what can it be used for? This can be used for checking the data given by any operator, any airship manufacturer, because they will give us the numbers of volume and payload. We can say, okay, this airship, if it comes to India and if it is flown in these operating conditions, we want this speed, this height, blah, 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 we can get a payload of only so much. So that's why I call it as the analysis mode, not the design mode. Okay? Or you can have one more scope, and that is the design mode, which means the customer say, I don't know which airship, I don't know how much size. This is the payload I definitely want to carry. Now you tell me whether it is 80 meters or 8 meters. Okay? It will depend a lot on the materials also, self-weight also. That's where we use the data about the existing technology. So remember, you can run this methodology in either of the 2 modes. Therefore, when you make the methodology for me, I am expecting from you an updated methodology for airship design as part of the assignment.